Mm-mm.
Anubis, a fixed-wing hand-launched pusher UAV designed and tested to meet all the competition mission objectives. The team aimed mainly to design, manufacture, and test an agile airframe with the highest quality at the lowest possible cost, along with being adequately both stable and maneuverable to be capable of achieving all the missions with high performance. The main materials used for manufacturing are plywood and balsa wood, in addition to carbon fiber and 3D printed materials. The main fuselage structure consists of two longitudinal sides. The wing structure is mainly spar semi-monocoque with a carbon fiber main spar. A high wing configuration with a wingspan of 8 feet and a 3-degree dihedral angle was iteratively chosen as a suitable design solution to ensure a high degree of stability and limit the induced drag. The airframe was modeled in FRR to analyze aerodynamic efficiency and ensure static and dynamic stability during flight. A stress analysis was also conducted on the wing using ANSYS simulation to get the results for static structure to make sure the wing is able to withstand the loads. For autopilot, we use Pixahawk Cube 2, a HERE 2 GPS, an RFD 900X, an onboard computer XU4 Odroid, and a GT4020 Emax motor, and for communication we use a Bullet AC. The UGV is a bi-wheel. The wheel was manufactured using 3D printed materials, BLA and TBU, to withstand the impact, provided with a tail to maintain the UGV balance. We were able to edit the mission planner code to meet the competition requirements by adding in the GUI a split button to run a script that splits the mission received from the judges, another one to load the grid file, then add the grid waypoints on the map, a button for loading the obstacles file and drawing it on the map, finally saving the full mission button that saves the whole mission to a file. Also, adding the generated new path button that launches the TA script to avoid the stationary obstacles, and adding the other team's UAV chaser to detect their movement and avoid it as a dynamic obstacle according to their received telemetry. As the ODLC task has the maximum score in the mission, hence, it had our maximum concern and effort, and over 728,000 image dataset was generated using OpenCV library. Our whole ODLC system works autonomously using different machine learning modules except for localization. The YOLO V5 machine learning algorithm module was trained on the dataset and used for detection. For the localization, the Vincentity's formulae with the photogrammetry were implemented on the algorithm. Different CNNs were trained for the classification task with its different categories. The whole system was tested on over 11,000 generated images with real objects, photos from OpenCV, and finally tested on around 300 aerial images taken by the UAV. Mapping task, we used the best software and photogrammetry field. Pix4D Mapper is an image processing software that is based on automatically finding thousands of common points between images. In order to get high accuracy results, a high overlap between the images is required. Therefore, the image acquisition plan has to be carefully designed in order to have enough overlap. Also, the camera should be maintained at a constant height. The software generates an editable orthomosaic with input of aerial images acquired using a grid flight plan. Several tests were done on the subsystems and components in order to ensure that the design is reliable and the whole system integration works as designed as possible. To ensure trim at a positive angle of attack, The center of gravity was balanced by placing the camera and its gimbal at the front part of the fuselage. The wingtip loading test was conducted on the wing to ensure that its structure is able to support the airplane weight. Dummy weights were made and uniformly distributed on the wing to test the structure's ability to withstand additional loads on the gross weight of the aircraft, in order to ensure structure integrity and reliability during different mission parts. Also, the load test was performed using suitable weights placed on the wing. Several parachute configurations were taken into consideration. Using the parachute sizing equations, we designed several parachutes with different configurations and diameters. Then, we tested them all in different situations: different UGV weight, drop from different heights, different wind conditions, to choose the parachute that suited the mission. Autopilot, GPS, battery, and motors performance measurements were recorded to evaluate their performance. Before performing an autonomous mission, it was tested on the Mission Planner simulator to ensure safety for the airframe, while obstacles were added to test the algorithm of avoidance. Also, a simulation of dynamic obstacle of a UAV was used to test the performance. GoPro Hero 5 is used with a minimum altitude of 197 feet for a coverage area around 800.584 square feet, producing images with ground resolution about 0.05 feet with capture rate of a photo every second and a half. The Sky Thunder team plan is to accomplish all the mission tasks. After passing 12 flight tests, Anubis perfectly accomplished the autonomous flight, ODLC, and static obstacle avoidance tasks, while for the dynamic obstacle, it was only simulated. Airdrop mission was done, but with some difficulties in drop accuracy as the conditions were unfamiliar. Also, driving to location is not fully tested due to the using of new design. The estimated score was planned after the aircraft performed 12 flights, with 30% of manual takeover. For the timeline task, the team was able to do it with average of 7 minutes and with less than 2 minutes of post-processing time and without using any timeouts. Using a mission similar to the previous competition airfield, the team was able to accomplish all the waypoints with high accuracy, scoring an average of 0.95 of the autonomous flight score. For static obstacles, the team was able to avoid all the obstacles successfully and autonomously in all the flight attempts. Using 10 alphanumeric objects, 5 each mission, scattered randomly in the flight path, the team reached 85% of the characteristics and locations from 20 feet average on all flights. On average, the team achieved 87% of the ODLC task points. The air delivery task was done only on 5 flight tests, with average accuracy of 22 feet and drive to location of 7 feet, achieving an average of 0.6 of the total task score.